Hi everyone, welcome to this video. We're going to try to develop the exercises 1 to 6 of chapter 23, Measuring a Nation's Income. Remember, this is a book of Gregory Mankiw, Principles of Economics. So the first question says, what components of GDP, if any, would each of the following transaction affect? Explain. So the first is the situation where a family buys a new refrigerator. So naturally, we are talking in the component of consumption. And inside this consumption, we can think about durable goods. So durable goods are related more to devices. But in the total set, we talk about consumption. Second, B. Aunt Jane buys a new house. This is a tricky question for GDP measurement. Why? Because at first you can think that when you buy a house could be related with consumption. Actually, no. This is more about investment. So this is because there is an assumption that it does not belong to consumption. So for this reason, every time we buy a new house, this is considered in investment. C. Ford sells a Mustang from its inventory. Well, remember, inventory is counted as itself, so like a purchase. So for example, when this Mustang it wasn't sold in the previous time, anyway, it is counted in inventory, and it is counted with the value of the market value as a purchase for the same company. So then it was already counted before. So then we can think that it subtract inventory, and at the end of the day it increases consumption. So then it could be that, or it should be that the final effect should be zero, because inventory and then the increases consumption, the final effect was zero, because actually before, remember, it was already counted. You buy a pizza. Naturally, this is consumption of perishable goods, and it is counted for the GDP. And E. California repays Highway 101. So then we are talking about stattal expenditure, so government expenditure. So naturally it should be inside the government expenditure. F. Your parents buy a bottle of French wine. So then there is an increase of consumption, but there is an increase of imports, and then a decrease in net exports. So at the end of the day, when you buy an imported good, it is considered as zero effect because of the net exports decrease. Honda expands its factory in Marysville, Ohio. So even Honda is not American, the production is in the States. So then this investment is part of the factor of production as plant and equipment, and naturally it goes via investment for the GDP. Second question. The government purchases component of GDP does not include spending on transfer payments such as social security. Thinking about the definition of GDP, explain why transfer payments are excluded. So let's start this question with the definition of gross domestic product. The gross domestic product is the market value of all final goods and services produced within a country in a given period of time. So then when you provide a transfer via social security, there are no good or service produced in this transaction as exchange, right? So then this is natural expenditure from government then this is negative, plus the income received make if made effect equal to 0. So at the end of the day, this not considered for GDP. 3. As the chapter states, GDP does not include the value of used goods that are resold. Why would including such a transaction make GDP a less informative measure of economic well-being? Just imagine a situation of a brand new car. Once it is sold, without being in inventory for GDP, it will be at a value once because the consumption is done. Imagine that this is sold 4 times in the same year. If this happens and you count that transaction for the GDP, you are making 4 times the same product. So then you are adding more value to the GDP that actually it does not exist. And then GDP would take into account all the transaction of this good. So then for this is like different times counted. 4. Below are some data from the land of milk and honey. So we have here a table. First we have this first column, the year. So we have 2013 to 2015. And then we have this, the price of milk and the quantity of that product. And the same thing for honey and with the prices and quantities. So first, compute nominal GDP, real GDP, and the GDP deflator for each year, using 2013 as a base year. So first, the nominal GDP. So the nominal GDP for 2013 should be the prices of 2013 times the quantities. This M stands for milk and this H for honey. So here everything value with year 2013. Then the GDP of 2013 nominal should be 1, which is the price of this one, times the quantity, which is exactly the quantity 100, plus 2, which is the price of honey, times 50. Then we have 100 plus 100. So the nominal GDP for 2013 should be 200. What about 14? Exactly the same. We value everything in 2014. Then we have 1 times 200 times 2 times 100. At the end, we end up with 400 for GDP nominal 2014. Then, nominal GDP, we already have this one, 200 and 400. What about 15? It's exactly the same. You just like replace by the values of 2015, 2 times 200 times 4 plus 4 times 100. Say we have 400 plus 400. So at the end, we have 800. What about the real GDP? The real GDP first, remember, we need to have base year. They already provide the base year, which is 2013. So naturally, because you are valuing these quantities with the prices of base year, then the real GDP for the nominal GDP for the base year is exactly the same as the GDP for the real one. Okay? Then we have that the GDP for 2013, the real is exactly the same as the nominal because we are talking about the base year 2013. Then for 14, this is the difference. Instead of computing for 2014, you add 2013 prices for honey and milk. So we have 1 and 2, and then we end up with 400, sorry. Then now we move with the 13. So sorry, with the 15. So then, so 14 we already did it, and 15. We have prices again, 2013 times the quantities of 2015, and then we end up with 200 plus 200, so we have 400. So then we already have nominal, real, and then we are going to talk about deflator. So the equation of the deflator is the nominal GDP over real GDP for that year. So then it should be something else. Real deflator for 2013 is exactly equal to 100. I'm going to show here, sorry, is exactly equal to 100. Why? The nominal GDP is 200. The real GDP is exactly the same because it's the same year. So times 100 is 100. Then for 14 should be the nominal, which is 400, over the real, which is 400. Then again, the GDP for the GDP deflator for 2014 should be exactly 100. And then for 15 should be 800, which is the nominal, over the real, which is 400. Then we end up with 200. Then the B part. Compute the percentage change in nominal GDP, real GDP, and GDP deflator in 2014 and 2015 from the preceding year. For each year, identify the variable that does not change. Explain why your answer makes sense. So here we have the GDP nominal, and then we are going to start to make the change. So remember, the percentage change should be final value minus initial value over initial value times 100, and you have the answer in percentage. So then we have GDP for 2014 nominal minus the initial, which in this case is 13 nominal, over 13 nominal. So you just replace, and then we end up with 100%. So naturally, you see here that there was an increase of 100% from 400 compared with 200. Then for 15 is exactly the same, just 15 minus 14 over 14, and then you have 800 minus 400 over 400, and then you have this time exactly the same, 100%. You see here an increase, double. So anytime you have double quantity, this is like 100% increase. Then the real case, we have these numbers, and then the same formula, final value minus initial value over initial value times 100. So we have 14 minus 13 over 13, but in real terms. So we have, this is the case for 14, so we have an increase of 100%. And then for 15, we change 15 minus 14 over 14, and then we end with 0%. Why? Because it's exactly the same quantity. So here we have the percentage for 15, 0. So then we are going to move with the deflator that we already computed before, and then for the percentage change for 14, so we have 14 minus 13 over 13, but in this case the deflator, so we have 100 minus 100 over 100 natural. This is 0%. The deflator, it didn't change at all. And then for 15, so we have 100%. Then let's summarize the stuff. So we have an increase for the nominal GDP of 100 over year, and the real GDP we have an increase for 14, and the same for 15, and the deflator, so we have 0% and 100%. So let's try to understand a little bit better. So why, you can see here, for example, let's start with 14. So we see here an increase of 100% of nominal GDP. Why? Because we have the same prices. You see here that the quantities double, right? So for this reason it makes sense a change in nominal GDP. Why a change in real GDP as well? Well, because the price it was exactly the same. It was steady. It was exactly the same, and then the movement was just represented because of quantities. So every time we have an increase in quantities, it's expected that the real GDP increase. So then we have this one. And why the deflator is just 0%? Because in this particular case, nominal is exactly equal to this case nominal is exactly equal to the real. So we have the deflator from one year to another, it was exactly the same. Why? Because remember, we have for 14 the deflator, which is nominal over real, and 13, and 13 is the base year. So for this reason the deflator is 100. And then during the next year, the deflator was nominal over real as well. And remember that the nominal was exactly the same as real because you are valuing the same prices as the base year. The prices didn't change. So for this reason, the deflator was exactly the same, was 100. So for this reason, it wasn't an increase. Let's move for the situation of 2015. It was an increase of nominal GDP of 100%, but instead of the change of 14 that it was based on change in quantities, it was because of prices. Have a look here that the quantities remain exactly the same. The change was provided just because of the changes in price, 2 and 4. So for this reason, the nominal GDP is 100%, the change. What about the real GDP that we end up with 0% change? Well, this is because since the prices, it was the cause of the change, but the quantities remain the same. Naturally, the real GDP is exactly the same as before. And then the deflator is 100 increase because remember, nominal over real. And nominal over real, because nominal was higher in this case, the deflator actually was 300. So for this reason, we see here an increase. Okay, then did economic well-being rise more in 2014 or 2015? So first, every time you want to monitor the situation of well-being, you need to focus on real GDP because it already rolled out the changes in prices. We know that the change in 14 was 100 and the change in 15 it was 0%. So naturally it was a better or was an increase for the well-being in 2014 instead of 2015. And then 5. Consider an economy that produces only chocolate bars, and then in year 1 the quantity produced is 3 bars and the price is 4. In year 2 the quantity produced is 4 bars and the price is 5. In year 3 the quantity produced is 5 bars and the price is 6. Year 1 is the base year. So then, what is the nominal GDP for each of these 3 years? So then, let's summarize all that information in a table to make it easier. So we have year 1 quantity and prices. So for year 1 we have the quantity is 3 and the price is 4. Then for year 2 we have quantity produced 4 and the price is 5. In year 3 the quantity produced is 5 bars and the price is 6. Then we already know the nominal GDP should be price times the quantities. In this case we just have one product, so it should be this computation. So we have 4 times 3, so we end with 12. And then for year 2 we have price 2 times Q2, so we have 5 times 4. Then we have 20. Then for the other situation, so we have 6 times 5, So we have 30. And then, what is the real GDP for each of these years? So we have GDP nominal exactly equal to the real for this year 1, because this is the base year, and then the real 1 should be 12. Then for the 2, this is the change, price 1 instead of price 2, because we are computing the real GDP. So then we have 4. Here we have 4, which is the price, times 5, times 4, which is the quantities, and then we have 16, and then price 1 times quantity, this one, so it should be 5, right? So here definitely it is a mistake, so it should be 4 times 5, so we have 20, right? So then we have this one, the nominal ones, and then the deflator for year 1 should be nominal over real for year 1. So we have this one. Remember, this is 20 because it was wrong, because it was 4 times 5. And then we have the deflator for 1 should be exactly 100 because it's the base year. For deflator for 2 should be nominal over real, so we have nominal 20 over 16, so we have 125. And for the third year should be 30 over 20, not 24. And then we have 30 over 20. Then, if I'm not wrong, should be 150. Then 6. Consider the following data on US GDP. So we have here nominal GDP in billions of dollars. For US GDP, 15,676, and for 2002 this number, and the GDP deflator with the base year of 2005, so we have these two numbers. So then the first question says, what was the growth rate of nominal GDP between 2002 and 2012? Hint: the growth rate of a variable x over an n-year period is calculated as this formula. Why it is different as we calculated before? Because as you can see here, we are not moving from one year to next year. It means not 2002 and 2003. We're moving from 2002 to 2012. So then we're going to make this different computation. So then should be the different percentage should be x final, which should be the final year over initial year. This is the difference here. Over, so we have this one, and it's not over, so we have this elevated to 1 over n. And n should be the number of years. So it should be 2012 minus 2012. So it should be 10. Then we just replace the final, should be this one, 15 over 10. And then 2012 minus 2002, which should be 10. Then we just make this division here, making with 4 decimals, and then we elevated this. If you have different numbers, maybe because you are taking just these 4 numbers, and I computed in Excel and I keep all the decimals and I just represent here the 4. But if you have the just 4 and it's really similar, it is not wrong, it is okay. And then we have this one. This was the increase for nominal GDP of 3.94%. Then, what was the growth rate of the GDP deflator between 2002 and 2012? Exactly the same, just instead of nominal GDP here, we put here the deflator, which is 115 over 92, and then we have this value for decimals, and then we elevate this number to 1 over 10th, and then at the end of the day we have an increase of the deflator of 2.2627 approximately percent of increase. Then what was the real GDP in 2002 measured in 2005 prices? Well, we don't have that information as easy, because actually we have this in nominal. However, we can extract from this formula from the deflator, because we already know that the deflator is exactly equal to GDP nominal over GDP real, right? So then when you make this computation, so you have 2002 the nominal over the real 2002, and then you automatically know that you already have that information, the deflator, and you have as well nominal. So there is one equation, one variable, which is the real, so I can collect this term to find out the real value. So then the GDP real, this is dividing, so then it goes to the other side, and then this goes to the other side. So as you can see here, we already have isolated the value that we need to know, which is the real value for 2002. So then should be nominal for 2002, it should be exactly equal to this 10 over 92.2. So then this computation, so you have the GDP real for 2002 should be around $11,542. Then what about 2012? It works exactly the same, just with the numbers of 2012, and then you replace 515,676, the value of the nominal GDP, over the GDP deflator, and then we have this value for GDP 2012, $13,584. Then what was the growth rate of real GDP between 2002 and 2012? So here we already have the numbers, so we just use the formula that the exercise provided, and then we just replace for those numbers, we make the division, and we end with this value, and we elevate this to the 1/10th, and then we have the real increase. It was 1.64%. Then was the growth rate of nominal GDP higher or lower than the growth rate of real GDP? Explain. So we know that the percentage change for nominal, it was 3.94%, right? And the real, it was 1.64. So why we can automatically extract from this one? Anytime we have an increase in nominal higher to the real, which is this is the case, it means that this all increase, it was not only represented by quantities but also by prices. And how we can have here, we have here actually that the GDP deflator for 2012 is higher than the GDP deflator for 2002. So then automatically we already know this computation. So at this situation we know that the GDP deflator for 2012, it was higher because it's important to verify here that the nominal for 2002, it was higher, in this case was lower than the GDP for real, right? Which makes the deflator lower than 100. So then at the end of the day, it was an increase in prices, but the increase of the real GDP, it was positive. So it means that this all just nominal was not because of prices only, but also because of the increase of quantities. Okay, so I hope it has worth. You have clarified some computation of the real GDP, nominal GDP deflator. And naturally, see you next videos. Bye bye.